Okay, in this video we're doing finding the angle between vectors, and it's very heavily based on the dot product. In fact, there's the formula for it. So we'll do an example of it first, find the angle between A and B there. So we'll need a few key components. In our case, if we relate to the formula, A is like our V and our B is like W. So pretty much cos of the angle between these is going to be A dot B over mod A mod B. That would be the formula we'll be using. So let's just work out mod A and mod B first. So mod A is square root of 3 squared plus minus 2 squared, which is 9 plus 4, which is root 13. And mod B is going to be square root of 1 squared plus 7 squared, which is root of 50. And then if we look at A dot B, that's going to be 3 times 1 plus minus 2 times 7, which is 3 take 14, which is minus 11. So cos of theta equals minus 11 on the top, and it's going to be root 13 times root of 50 on the bottom, and then we can just put that in. Theta equals inverse cos of all that stuff. All right, so we can do that and we'll see what we get. So here we go. Inverse cos of minus 11 divided by root 13 times root 50. .016, make sure you're in degrees, which I was not. And I might actually have to do it again. Inverse cos of minus 11 over root 13 times root 50. There we go. 115.559 or 115.560 degrees once we round it. So that's an obtuse angle. And that's because these vectors are sort of pointing up. A points 3 to the right and 2 down, so A is sort of pointing down like that. And then B points 1 to the right and 7 up, so kind of more up than right. And what we've just found is that the angle between those, so this angle sort of hanging out down here, is about 115.560 degrees, just like that. All right, now that's probably the hardest question we're going to do in this video. Next, we need to check whether they're perpendicular, and we have this handy fact here. If the dot product is 0, they're perpendicular, and I'll show you why. Well, let's just assume that v dot w is 0, then this whole thing on the right-hand side would be 0. We'll just get cos of theta equals 0. And if I try and do inverse cos of 0, we'll see what happens. We just get 90 degrees, which means they're at right angles. So that's a really handy fact. It's going to be one of the most useful vector facts we know. If the dot product of the vectors is 0, then the vectors are perpendicular. It means they're at right angles to each other. So A dot B, if we work that out, it's going to be minus 1 times 2 plus 5t, which is minus 2 plus 5t. And we wanted this to equal 0. So 5t equals 2. Therefore, t equals 2 over 5. And that's what you do for that question. Find all vectors which are perpendicular to 3, 4. So let's just say the vector, it looks like this, AB, like those are the two numbers in the vector. AB dotted with 3, 4 is supposed to equal 0. So that's 3A plus 4B equals 0. And then we can sort of just think about what the vector is going to look like. So maybe 3A equals minus 4B. So A is going to be minus 4/3 of B. So pretty much what you can do is you can say, well, the vector down here, B can be any number you want, and that's going to be minus 4/3 of the number up the top, where B is a real number. So for example, if I picked B being 9, this would be minus 12, because if I look at it, and I go minus 4/3 of 9, that gives them minus 12. Yeah, so that's really good. That's an example of one vector which is perpendicular, and when I say perpendicular, I mean at right angles. All right, last one, consider these 3 points. We want to determine whether ABC is right angled, and if so, find the right angle. So we're going to have these 3 points, A, B, and C, and we're going to want to make vectors. So we've got to check all 3 of these angles. So with this angle, we've got to check CA dotted with CB. We've got to check that vector for that angle. For this angle, we'll get to it later, but let's do CA dot CB first. So let's work out all our different combinations. Maybe like CA as a vector is going to equal, how do I get from C to A? I go down by 3 and I go up by 4. CB, if I check that, well, I'd go up by 1 and I'd go up by 2 to get from C to B. And if I do CA dotted with CB, that's going to be minus 3 plus 8, which does not equal 0. So that's not a right angle because the dot product did not equal 0. All right, next we've got to check this one. So maybe we'd be looking at the vector pointing out from B to A. And we'd also be looking at the vector pointing out from B to C. So B to A is going to equal minus 4 and then 2. And then B to C is going to equal minus 1 and then minus 2. So if I dot them together, BA dot BC, I'm going to get 4 take 4, which is 0. So, well, pretty much angle there is a right angle. Therefore, ABC is a right angled triangle. And the angle at ABC is the right angle. There's also another way you can check if the triangle is a right angle. What you can do is you can get the length of all 3 sides and check if it satisfies Pythagoras. That would be another good way to check, but it would take a bit longer than doing this dot product thing.